Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we try to bring best content for you. Ever wonder why the sea is salty and what makes it so? How long does a drop of water stay in the ocean, or a grain of salt, or a molecule of oxygen? Do you ponder over the secrets lurking beneath the shimmering blue surface? The ocean, it's more than just water. It's a complex, ever-changing mixture teeming with elements, each with its own unique story. Today we're diving into the depths of this fascinating topic, the residence times of elements in seawater. In the simplest terms, residence time refers to the average length of time an element stays in the ocean before it is removed. Now, let's dive a bit deeper into this fascinating concept. Imagine the ocean as a grand, bustling hotel where elements are the guests. Some guests, like oxygen and carbon, are long-term residents, staying for millions of years. Others, like iron and manganese, are rather fleeting visitors, checking out after just a few hundred years. But how do these elements, our oceanic guests, get their room keys in the first place? Well, they enter the ocean, or check in, through various sources. These include rivers, which carry dissolved elements from the land, atmospheric deposition, where elements are carried down by rain or dust, and hydrothermal vents, which spew out minerals from the ocean floor. But like all good things, their stay must come to an end. These elements are checked out or removed from the ocean in several ways. They may precipitate out of the water as minerals, be taken up by marine organisms, or be carried away by oceanic currents. So, how do scientists calculate the residence time of these elements? It's a bit like a grand scientific ledger. They tally up the total amount of an element in the ocean and divide it by the rate at which that element is added or removed. This gives them the average length of time an element stays in the ocean, or its residence time. This isn't just a fun fact for trivia night, though. Understanding residence times has profound implications for our understanding of the ocean. It helps scientists predict how the ocean will respond to changes in element input and loss. For instance, if more carbon is added to the ocean due to human activities, how long will it stay there? What impact will it have on marine life? These are the kind of questions that residence times can help answer. Understanding residence times is crucial for marine biologists and oceanographers, as it helps them predict the ocean's response to changes in element input and loss. Different elements have different residence times. Some are fleeting visitors, while others are long-term tenants of the ocean. Imagine the ocean as a bustling city teeming with a myriad of elements. Some elements, like helium, are akin to tourists, briefly visiting before moving on. Due to its light and non-reactive nature, helium doesn't stick around for long. Once it's released into the ocean, it quickly escapes back into the atmosphere, giving it a residence time of just a few weeks. On the other hand, elements like sodium and chloride are the long-term residents of our oceanic city. They're like the old couple that's lived in the same house for decades. They're highly soluble and don't react easily with other elements, which means they're not in a hurry to leave. Sodium and chloride have a residence time in the order of tens of millions of years. Then there are elements like iron and manganese. These elements are the commuters of our city with a moderate stay. They're reactive and can be removed from seawater through processes like precipitation and adsorption onto particles. Their residence times can range from a few hundred to a few thousand years. Why is this important? Understanding the residence times of elements helps us to understand the health and history of our oceans. For example, the presence of certain elements can indicate pollution, while others can reveal information about the ocean's past climate. The ocean, like a city, is a complex system, and every element plays a part. Some elements stay for a short while, others for an eon, but each one contributes to the overall function and health of the ocean. Just as the residents of a city make it what it is, the elements in the ocean give it its character, its challenges and its beauty. And just like in a city, the length of stay of each element in the ocean tells a story about its role, its interactions and its journey. From mere seconds to millions of years, the residence times of elements in the ocean are as diverse as the elements themselves. So, we've taken a deep dive into the residence times of elements in seawater. We've journeyed together through the fascinating world of marine biology and oceanography, exploring the mysteries of residence times. We've discovered that the residence times of elements in seawater vary widely, from mere days to millions of years. This variance, as we've learned, is largely due to the different processes that either remove or add these elements to the ocean. We've also learned why understanding residence times is so crucial. It allows us to predict how the oceans will respond to changes, whether they're natural or human-induced. It's like having a crystal ball that gives us a glimpse into the future of our oceans. Moreover, we've delved into the concept of staying power of elements. Some elements, like gold and uranium, have long residence times, making them old sea salts. On the other hand, elements like iron and aluminum have short residence times, being young sea salts. This knowledge equips us to better understand the chemical composition of sea water, the cycles of various elements, and how they interact with sea life. It's an invaluable tool for scientists studying the marine world. As we continue to explore the world's oceans, the concept of residence times will undoubtedly remain a key tool in our oceanographic toolbox. Until our next deep dive, stay curious and keep exploring, and subscribe us for future videos.